A space elevator is a hypothetical structure that would extend from the surface of a celestial body, such as Earth or a moon, into space. The idea behind a space elevator is to create a fixed, stationary structure that would allow people and cargo to be lifted from the surface of a celestial body into space without the need for rockets or other forms of propulsion. The concept of a space elevator was first proposed in 1895 by Russian scientist Konstantin Tsiolkovsky, who suggested that it might be possible to build a structure reaching from the surface of Earth to the height of the geostationary orbit, approximately 35,000 kilometers above the surface. There are several technical challenges associated with building a space elevator, including the need to develop materials with sufficient strength and durability to withstand the stresses of such a structure, as well as the need to find a way to anchor the structure to the surface of a celestial body. To date, no space elevator has been built, and it is not clear when or if one will be constructed. However, the concept remains an active area of research and development, and some experts believe that it may be possible to build a space elevator within the next few decades. There are several technological advances that would need to be developed in order to create a space elevator, including strong, lightweight materials. A space elevator would need to be made of materials that are strong enough to withstand the tremendous stresses of the structure, as well as the weight of the payloads being lifted. Advanced propulsion systems. To lift payloads from the surface of a celestial body into space, the space elevator would need to have some form of propulsion system, such as a linear motor. Anchoring system. The space elevator would need to be anchored to the surface of a celestial body in order to keep it stationary. This would require the development of an advanced anchoring system that could hold the structure in place. Robust power systems. The space elevator would need to have a reliable power source to operate its various systems, including its propulsion system and any equipment used to lift payloads into space. Advanced controls and guidance systems. To ensure that the space elevator operates safely and reliably, it would need to have advanced controls and guidance systems to monitor and control its various systems. In addition to these technological advances, it would also be necessary to develop the logistical and organizational capabilities needed to build and operate a space elevator, which would be a complex and challenging undertaking. A space elevator has the potential to revolutionize space travel and make it much more accessible and affordable for a wider range of people and applications. Some of the potential benefits of a space elevator include lower cost. A space elevator could significantly reduce the cost of getting payloads into space, as it would eliminate the need for expensive rockets and other forms of propulsion. Increased safety. A space elevator would be much safer than current methods of space travel, as it would eliminate the need for risky rocket launches and re-entry maneuvers. Greater accessibility. A space elevator would make it much easier for people and cargo to access space, which could open up a wide range of new possibilities for exploration, research, and commercial activities. Increased capacity. A space elevator could potentially lift much larger payloads into space than current rocket technology is capable of, which would allow for the transportation of larger satellites, habitats, and other structures. Reduced environmental impact. A space elevator would produce no emissions or pollution, making it a much more environmentally friendly way of accessing space compared to current methods.